All right, let's do this. So here's where we actually solve for probability. So your answer should either be a decimal or a fraction here. Okay, so the biggest thing you need to do first before you find any probability is to find the total number of possible things that can happen. So if I'm rolling a die, how many options do I have? 6. If I'm flipping a coin, 2. So that's what you need to do first. So our random experiment this time is we're going to toss a fair coin 4 times. Okay, so you've got toss 1, toss 2, toss 3, toss 4. Each time I toss a coin, I have how many options?
2. Heads, tails,
2. Heads, tails, heads, tails. So how many total options do I have? 16. Remember, 2 times 2 times 2 times 2. I could write this as 2 to the 4th. And I have 16 total options. Okay, so those 16 total options are like true, 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 true. Or, yeah, true, true. We're talking heads and tails. So heads, 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 heads. Or heads, tails, heads, tails. That's where those 16 options come from. So that means every time I do a probability, it's out of 16. Just like every time you roll a die, it's out of 6. Every time you flip a coin, it's out of 2. Okay, every one of these are out of 16. Now, the scenarios they give you is what goes in the numerator. What is the probability of getting exactly 1 head?
1 out of 16.
Here comes that exact word again. When we did exactly in section 15.2 and 15.3, what did we use? Permutations or combinations?
Permutations. Or combinations.
Permutation because it has to be in order or something.
It's computation because it don't tell you exactly.
Okay, so exactly 1 head. Does that tell me my heads has to come first? Or my heads
That's
has to
what I
come
was
third?
saying too.
No, so it's going to be combinations. This doesn't tell me where the heads has to fall. Okay, it can fall in any one of the 4 slots. So this should be a combination.
Okay.
How do I write exactly 1 head with a combination?
1 and 1.
4C1. I'm tossing it 4 times, and I want one of them to be heads.
So 4C1 over 16?
Yes. So you would plug in 4C1 divided by 16 to get your answer.
So what button?
So you're going to hit 4, Victoria, and then you're going to go to math.
Go ahead, alphabet. And
Scroll over to probability, and it's choice 3, or is it 4? It's 3, and then you're going to hit 1, hit enter, and then divide that by 16. 0.25 or 1/4. Okay, so if they're looking for a decimal, you're going to want 0.25. If they're looking for a fraction, you're going to want 1/4. Okay, part C. At least 1 head. Okay, at least. We're still using combinations. Exact and at least, at most. Okay, those are all combinations. What does at least 1 head mean?
No less than 1.
No less than 1. So that means 1 or more. So I can get 1 or I have to stop at 4. I'm only tossing it 4 times. So I need to take all of that into consideration for the top. So your top's not just going to be 1 little piece. It's going to be a bunch. So I'm going to erase this for a minute.
Yeah.
Okay. So I need to write, I want exactly 1 head. So 4C1. Or now I need to write 2 heads.
Oh.
So 4C2. Then I need to write 3 heads.
4C3.
And I can have 4 heads. So 4C4. So you would have to plug the entire top in, hit enter, and then divide by 16. Please make sure after you plug in the top that you hit enter. So it adds all of that up first before we divide by 16.
Right.
0.9375. This also comes out to be 15 out of 16. There's another way we could also have solved this problem. So at least one head means I could have one head, 2, 3, or 4. What does that not include?
0.
0. So I could have done the complement. So 1 minus the fact that I could have 0 heads. And that would have also given me 15 out of 16.
Huh?
What does 1, 2, 3, and 4 not include? In fact, you have 0. So remember, I taught you the complement, and they both have to add up to equal 1. So if you find the opposite of this and subtract it from 1, it will give you that as well.
I will.
All right. Let's take a look at the next one. We've got 6 questions, true or false. The first thing I need to do is find the bottom number for all of my fractions. So each question, I have how many options?
2.
2. How many times do I have to pick an answer? 6. So you could have written it's 2 options, 2 options, 2 options, 2 options, 2 options. I'm going to shortcut it now. I've got 2 options each time, and I've got 6 questions. So that's 2 to the 6th power. Which should come out to be 64. So that means that each one of these will be out of 64. So in part B, they want exactly 3 truths. How do I write exactly 3 truths?
6C3.
6C3. I have 6 questions and I want 3 of them exact.
Next one, 3125.
3125, which is also 5 out of 16. At most, 2 falses. So what does at most mean?
2 is the
2 is the highest I could have. So I could have 2. How do I write 2?
C2 or 6C2.
Okay. What else does that include?
C61
6C1
C60.
and 6C0. At most, true falses means I have 2, 1, or none.
Did you say that it's always 6?
So these ones are out of 64. Oh, no, that's just it reduced. That's all. It's not always out of 16. Because it would have come out to be 20 out of 64, which reduces the 5 out of 16. Okay. Good question. Anybody get an answer for C?
22. I don't want to know what is it.
0.34375.
0.34.
Which comes out to be 11 over 32. when it's reduced?
How do you change it to a fraction again? You go to math.
Math, choice number 1.
On the test you wanted fraction.
On the test you're taking tomorrow, I don't care. Okay, and then again, your final exam, if your answers are in decimals, you'll know to put it in a decimal. Okay. Probability that an answer key has at least 3 falses. So what does at least 3 mean?
3.
3 or more. So that means 3, 4, 5, or 6. So we've got 63 or 64 or 65 or 66.
Six, five, 625.
0.65625 or 21 30 seconds.
Good answer.
Okay, before you kill me, take a look at both of those. The one we just did before and the one we just did now. This was 2, 1, and 0. 3, 4, 5, and 6. Say that again, Andy? It's the opposite. So instead of plugging all of this in, you could have literally done 1 minus the answer you got up here. And you would have still gotten the correct answer. Again, I don't care which way you do it, but it has to be the exact opposite in order to use the complement. So if for some reason that would have said at least 4 falses, you couldn't have used it. Okay. Questions? All right. Let's get into some that you should be super familiar with. Now we're talking about a 4-character password. It's made from numbers and letters, which are case sensitive. Okay? First thing I need to do is find what the bottom number is. If I am case sensitive, how many letters do I have?
52.
52. Okay, I can have letters and numbers. So that gives me how many options?
62.
62. How many times do I have 62 options?
4.
4, because it's a 4-letter password. Does that make sense? I've got letters and numbers. Don't worry about finding the answer for this. So instead of actually plugging it in and getting an answer, because it's going to be huge, excuse me, each one of these is just going to be out of 62 to the 4th. Okay, so just make it out of 62 to the 4th, because if you plug in and you get the number, and when you go to divide to actually get your probability and you plug in that big number wrong, you're screwed. It's easier to plug in 62 to the 4th.
Right.
Okay. B says the probability that a password will use no even digits. So now I'm taking away all of your even digits. How many choices am I taking away?
5.
5. I'm taking away 0, 2, 4, 6, and 8. Taking away 5 options. So if I started with 62 and I'm taking away 5, I have how many options now? 57. How many times do I have 57 options?
4.
4. So that's 57 to the 4th divided by 62 to the 4th.
Could that be your answer?
Huh?
Could that be your answer too?
What?
Never mind.
No, you would actually have to plug it in.
Any delivery job?
What?
Am I supposed to use?
Oh, you're talking to him?
He said it.
Oh.
Huh?
So we gotta write this whole decimal. Hey, I do it though.
Just a quick.
No, like rounded to 3 decimal places will be fine.
She asked me what they told me.
But that's still, could that be like
It's
the same as 57 or 62.
I'm playing. Going through the day.
Irritating.
Let's see your calculator.
They ain't got it. Look at houses. That's what it's cool.
I'm selling coke.
No.
No.
That was a
I'm
good
good.
thought, though.
That's already.
Yeah, that's what I was asking. Can you just simplify?
No, you can't. Because Marcus just said the same thing. Can you just do 57 divided by 62 since it's to the fourth?
Yeah, but it's-
I just tried it, it doesn't work.
It's like 57 times 57 and then 62 times.
Okay. C says, stop. Why is it so hard? I'm talking and teaching. Zip it. A password that will start with a number and end with a number. So this one isn't quite as easy because you've got a little bit of stuff going on here. So I have a 4-character password. I want to start with a number and end with a number. So how many options do I have for each slot?
10.
10. It doesn't matter what I put in the middle 2 spaces. So what I have for those slots? 62. So in the top, you would multiply 10 times 62 times 62 times 10. And then divide that by 62 to the 4th. If you like it with the exponents, this could also be 10 to the 2nd times 62 to the 2nd divided by 62 to the 4th.
0.026.
I get to do my calculations.
Your calculations. Okay, this last one. Again, it's still at a 62 to the 4th because that was my original sample space. What is the probability that the password will use only lowercase letters?
30, would you use 36? Wait, no, 30.
Only lowercase letters.
So
So 26
to 4.
to the 4th. Or again, if you prefer to write it out, 26 lowercase letters in that slot, 26 in that slot, 26 in that slot, 26 in that slot. Okay, I don't care if you like to shorthand it or if you like to draw it out. Either way works for me.
0.0309.
0.031. Round it to 3 decimals, it'll be easier.
Okay.
Okay.
That's what I'm trying to tell them.
Okay, now we're gonna get into the old school probability that most of you are used to. Oh. Okay. Replacement is allowed. In Math 2, you should have talked about probability with independent and dependent events. An independent event means that your outcome doesn't change because you're putting stuff back. Once you've taken the marble out, you've put it back. So you have the same amount of options each time. Okay, so these are all going to be independent events. We're drawing 2 cards from a standard deck. We're putting the card back into the deck before we redraw the second time. How many different ways can 2 cards be drawn? The first time I'm picking a card, I have how many to choose from? The second time, 52, which is 52 to the 2nd power. Again, that's going to be a huge number, so just leave it as 52 to the 2nd for your denominators. So this is going to be out of 52 to the 2nd. We now need to take into consideration what we want to happen. I want to draw 2 kings. The first time, how many kings do I have to choose from?
4.
4. The second time I have
4.
4. Times. We don't ever subtract. It'll always either be multiply or plus.
0.005 or 0.006.
You said 0.005.
Yeah,
I have it as a fraction.
Oh,
Can you change it to a fraction for me?
no. 1/169.
He says no.
Bite.
I just want to make sure your decimals are right. And I have it on my answer key as a fraction. Okay, so 1 out of 169. C wants me to draw 2 face cards. How many options do I have for face cards?
Oh, wait, 8, just 8, 5.
No, I was saying no to 16. What did you say? 12. 12. Remember, your face cards are Jack, Queen, King. And then you've got 4 suits, which means you have 12 options. Both times, because you're replacing. So you've got 12 options both times. Which gives me
9 over 169.
9 out of 169.
Do the calculations. Calculation.
They got Mary's in line.
Okay, what is the probability of a red than a black? What's the probability I'll pull a red? How many reds?
20, no,
26.
26. How many chances do I have to pull a black card?
26.
26.
I mean, about color.
Right.
125.
0.25.
Which is 1
1/4.
I'm right.
What is the next one you add?
Okay, so take a look at D and E. D says red, then black. E says red and black.
I'm gonna add them. You can't. No. Might help me out.
So you don't replace it.
No, you're still replacing.
What is the probability for
What does red, then black mean? What do you need to pull first?
a red?
A red,
And
then a black.
No matter what order.
It doesn't matter what order when I put the word "and" there.
I do that.
So when you do this, you need to do red, then black, or black, then red. You need to take both orders into consideration in this one when it says "and," because it doesn't tell you the order that it needs to go in. So your red, then black. 26 and 26 out of 52 squared. Or 26 and 26 out of 52 squared. So basically, you're getting twice what this is.
So 1/2.
So this should come out to be 1/2.
I mean,
So if you get one of the orders, all you have to do is multiply it by 2 to get both. Make sense?
that was low key, common sense.
Low key common sense.
Yeah.
Okay. Finally, F. I want 2 diamonds. How many options do I have the first time I want a diamond?
13.
13. And the second time I want a diamond? 13.
13.
Just 13.
Yes. $1.16. Juan just said, dang, I need to learn my cards. So
I don't know.
here's your breakdown. Your board of fabulousness.
Trying to get a picture.
Go for it. You have 52 total cards. The total cards break down into 2 colors, red and black, which means you have 26 of each. Each one of the colors breaks down into 2 suits. Red breaks down into diamonds and hearts, so you've got 13 of each. Black breaks down into spades and clubs, you have 13 of each. And your cards go from ace to king. I will step out of the way if you would all like to get a picture of that.
Oh, I just wait for you to get in the way.
I don't want to be in that picture.
Come on, stand beside it.
Uh-uh.
Like
Come on,
the
do one of these.
little checks. Yeah, do that.
Like Vanna White.
Yeah. I'm not taking a picture until you do it.
Now you covering the board. You covering the side of the board, Miss Mary. I need
Got it.
the last numbers. Thank you. Or the letters, never mind. Oh, now you can do it so I can take a picture. For real. Okay, okay.
Is this better?
Let's go in the slideshow.
Sweet. Awesome. Okay. What's the difference between the one we just did and the one we about to do?
The card that you pulled.
I'm holding the card. So, how many different ways can two cards be drawn? The first time you pick a card, you have how many options?
52.
The second time you have,
51.
good,
That sound like
which
you.
gives you 2,652. Okay, so each one of these is going to be out of 2,652. Chickens.
This retarded little girl.
Not a nice word.
Come on, try it.
It's slow, little girl.
Okay. B says, I want to pull 2 5s. So, the first time I pull a 5, I have how many options?
2 5s. You got 4.
4. I have 4 5s in a deck.
Pardon the interruption. There's a bus change for this afternoon. Bus 51 will be Sphere Bus 334. And bus 272 will be Sphere Bus 316. So 272 will be 316. And 51 will be running in place of, excuse me, bus 51 will be 334.
Okay, so the first time I go to pick, I've got 4 5s to pick from. The 5 of hearts, diamonds, spades, and clubs. The second time I go to pick a 5, I have 3. Remember, I'm not pulling the card and putting it back. I'm pulling it and keeping it. So if I pull the 5 of diamonds, I only have 3 5s left to pick from. So this should come out to be 1 over 221. Don't be surprised if I just start putting answers down because I'm more worried about can you set it up than can you plug it in. I'm pretty sure y'all can plug it into the calculator by now. What is the probability of drawing 2 cards with number values? How many numbers do I have in each suit? 9. Remember, ace doesn't count as a number. Even though it represents the number 1, it's not a numbered card. So I have 2 through 10, which means I have 9 options. And 4 suits, so how many number values do I have in a deck? 36. I pull a numbered card, it's not going back in, which only gives me 35 the second time around.
It's 105 over 221.
Oh, I got 105.
You get me thinking of wrong.
What's the probability of drawing 2 black cards? 26 times 25. I've got 26 total black cards and 25 once I've pulled one. It was 25 out of 102.
Oh, I probably wrong with me too. It's 25 out of 2.
That is an even funnier private action show. Okay, what's the probability that I draw 2 cards of the same suit?
It would be 52,
13 times 12.
and then
You said, wait, hold on. Alexis, what did you say?
13.
Okay, so I'm going to take that into account. Tell me what you're going to say.
I was gonna say 52 and then like 25, right?
It's not 52 and 25. It's 52 and 12. Okay, so let me explain to you what both of these do.
Oh, right.
So-
I was thinking black and brown.
Alexis here started with, I'm looking at one suit and one suit only. So you're looking at diamonds or hearts or spades or clubs. Well, I have 13 cards to start with and 12 once I've picked one. What Alexis hasn't taken into consideration is the fact that it says of the same suit. That doesn't tell you what suit. So once Alexis does this, which is absolutely correct, he would then have to multiply his answer by 4 to represent hearts, diamonds, spades, and clubs. He's got to do this 4 separate times with all 4 suits. Okay? Marcus, however, took into account that I can pick any card I want to begin with. Any card in the deck. Once I've picked a card, whether it be a spade, a club, a diamond, or a heart, then I only have 12 to pick from after that because I want the same suit. So if I picked a spade, I only have 12 more spades in the deck. So this and this is the same exact thing. Okay, so both answers are correct, and they will both give you 4 out of 17.
Yeah. You said 4 out of 17?
So I don't care which way you logically need to think about it. Alexis's way was completely correct. Marcus's way was completely correct. There's more than one option to do some of these things, and that's okay. I don't care which way you get to the answer. I just need you to get there. Okay? All right. So basically what I've done now is I've given you everything we've just done in words. If it's an independent event, that means your chances have not changed. It's always out of 6 or it's always out of 52. Okay? Dependent means that I've kept it, which means every time your chance goes down by 1. Okay? So let's do some more examples. I've got 7 red, 5 green, and 8 yellow marbles in a bag. Each time the marble is chosen, it's placed back into the bag for the next draw. So the first thing I need to do is figure out what is my bottom number in this scenario. 20.
Hey.
I've got 20 marbles. So the first step you need to do is figure out your total. I've got 20. So now I want a red marble, then a yellow marble. What's the probability of me getting a red marble? 7 out of 20. What's the probability of me now getting a yellow marble?
8 out of 19.
No.
Oh,
It's put back in, so 8 out of 20. .14. Okay. I'm going to move across, that way I don't have to keep moving the screen up and down, up and down. Probability of a red, then a red. So I need a red marble first.
7 out of 20.
6 out of 20.
And I need another red.
7 out of, if you put it back, it's 7 out of
7 out of 20. This says it's being replaced. So this should come out to be 0.1225. I need a yellow, then a red. So probability of a yellow.
8 out of 20.
8 out of 20. Now I need a red. 7 out of 20. Comes out to be 0.14. I need a red, then a green. 7 out of 20. And 5 out of 20, which gives me 0.0875. C says red and yellow.
I think there's 7,
Add what?
7, 8.
What did the word and mean? We just did one. We just did
You
one.
do
Double.
7 times 8 plus 7 times 8, right? Or 8 times 7. I mean, does it really matter what order it's in?
Okay, remember, red and yellow means it doesn't tell you which order needs to come first. So I need to do red and yellow, or yellow then red. So I need to do 8, or no, it's 7 out of 20, right? 7 out of 20, and 8 out of 20, or 8 out of 20, and 7 out of 20. Or all I need to do is go back and double the one above it, because I already did red then yellow, which means this should come out to be 0.28. So again, if you see that word and, that just means twice one of the exact orders. And finally, E, green, then yellow. Which is 0.1. Okay, last one of these, and then we're into the last part of 15.5. This time, I'm not replacing. Nothing has changed, though. I still have 20 total. I have 8 yellow, 5 green, 7 red. A says I want red, then yellow. 7 out of 20.
5 out of 19.
No, 5.
Oh, 8.
8 out of 19. Okay, this time I'm not replacing it. So when I keep my marble, my total marbles go down, which should give me 1.47 or 0.147. Sorry, not 1 point. 0.147. What about yellow then red? I want a yellow first. 8 out of 20.
7 out of 19.
And 7 out of 19. Guess what? 0.147. Notice my top numbers didn't change. They just switched order. My bottom numbers also did not change. C says red and yellow. So I just multiply one of these by 2. So 2 times 1.147, which gives me 0.295. And finally, red, then red. So this looks like what? 7 out of 20.
6 out of 19.
And 6 out of 19. Okay. Again, the bottom number goes down because you're missing a marble. The top number is going down this time because I'm picking the same colored marble. So I've kept a red, which means I only have 6 reds left to pick from. Okay. Example number 3. I'm rolling a die 4 times. What is the probability of getting exactly 3 ones to show up? So I need to take into consideration this needs to be a 1, this needs to be a 1, this needs to be a 1, this needs to be anything but 1. What's the probability of me getting a 1?
1 out of 6.
1 out of 6. So each one of these choices is 1 out of 6. What's the probability of not getting a 1?
5.
5 out of 6. That's your complement.
You can't use the combination for that.
Okay, I'm going to show you a specific formula called the binomial probability formula. Okay, so this tells me that I have exactly 3 ones. But what this doesn't tell me is where the ones are going to end up. So if you do it this way, you would then have to take this answer and multiply it by 4. But there's 4 different ways I can have my ones. They can be in the first 3 slots. They can be in the last 3 slots. They can be in the first and the last 2. They can be in the first 2 and the last 1. There's 4 different ways to organize your ones. Or we can use what you see below, which is this. This is the most fantastic formula you will ever come across. in probability. It is fantastic. So, Marcus said we use the word exactly, which tells you combinations, correct? So, that's where this comes into play. N represents how many trials you're doing. So if you go back to that last example, how many times am I rolling the die? 4. So this would be 4. C. K represents the number of exact times you want it to happen. How many exactlies do I need? 3. Okay. This P represents the probability of the event that you want to happen. What was the event that I wanted to happen? I wanted those to be what? Ones. They're 1/6. Probability of a 1. This is I want a 1. Okay? Right beside it is going to be another set of parentheses. 1 minus P, which means we want the complement of a 1. Or in other words, not a 1. So if 1/6 gives me a 1, 5/6 gives me not a 1.
That's K.
Okay? Hold up. We now need to raise both of these to some power. Okay? How many times do we want a 1 to show up?
3.
3. So that goes here. This number goes here. If I want 3 1s to show up and I'm doing a total of 4, how many non-1s do I need? 1. So that makes this a 1. This number and this number must add together to give me this number. As we work with this, you're going to go, it's magical. And I'm pretty sure 2 of the release questions on the test that you were given, I've used this formula on. Okay.
So hold up.
Wait, so how did you get that 1 from before?
Okay, go back to this. I want 3 1s and 1 that's not. So I want 3 1s and 1 that's not.
Any other teacher would try to learn this.
Okay, you ready? Let's have some fun.
Am I ready?
Roll the dice 6 times. And I want exactly 3 1s to show up. So I need to start with my C. 6, C3. I want to roll it 6 times, and I want exactly 3. So 6, C3. What number specifically do I want to show up?
1.
A 1.
1 is
What is the probability of getting a 1? 1 out of 6. What's the probability then of getting not a 1? 5 out of 6. How many 1s do I want to have show up? 3. If I'm doing a total of 6 times and I want 3 1s, I want 3 that are not.
Answer. Very good.
That's it.
We don't have to solve?
Okay? Because this is a take-home test, and if you don't get it finished tomorrow, a lot of you don't have calculators at home. So I would accept this as your answer. Okay? Take a look at 5B. You're tossing a coin 4 times. What is the probability of getting exactly 3 H's to show up?
4C3.
4C3. I'm going 4 times, so 4C. I want exactly 3, so that's 4C3. What event do I want to show? I want a heads. What's the probability? 1/2. If it's not heads, then it's
Tails.
which means 1/2. Okay, how many heads do I want to show up?
3.
3, which means I need how many tails?
1.
1. I told you this is the most amazing formula you will ever see in your life. I love, 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 love this formula.
It looks complicated, but it ain't.
That's why I don't like the whole 1 minus P and stuff. I think that confuses a lot of you. So I try to ignore that a little bit.
Right, what P?
We have a P in there every single equation.
What are you talking about?
The P in the equation.
What P and what equation?
No, we was talking about equations. You said P.
Yeah.
You said those off.
I turned it.
So I was still figuring out where the P comes from.
Oh, you bounce it?
Yeah, we bounced.
What?
Oh my goodness.
What are you talking
Okay.
about, bro?
Okay, example 6. I've got 4 red, 8 green, 6 yellow marbles in a bag, and each time a marble shows in, it's placed back into the bag for the next draw. Okay, before you can even do probability, you need to know the total amount of marbles in your bag.
18.
18 total. Okay, so I want exactly 4 reds of 5 draws.
Okay, so 4, 5, C4.
5 C4. I've got a total of 5 draws, and I want 4 of them to be exact. What do I want to happen?
You want 4 reds out of 18.
So I need red. What is the probability that I will pull a red?
Or 18.
4 out of 18.
Or
In the next set of parentheses, I need not a red. So if there's 4 red out of 18, how many are not red? 14 out of 18. And
4 and 1. Love it.
so 4
So far.
and 1. Whoop, there it is.
Are we getting a take home test today?
You'll get it tomorrow.
Right.
Tonight you're gonna work on the rest of that worksheet that I gave you yesterday.
Okay, so Friday, I'm gonna bring it before we go on.
You might even finish it tomorrow before you walk out of this room, boy.
that'd be a
That would be truly ideal, because then you won't have to try to get it up here and hunt anybody down or whatever.
Hey, get us in this man.
B, we have exactly 3 greens after 10 draws.
Okay, so 10.
10 C3. I want a green. What's the probability?
3 out of 18.
3 out of 18. And finally, not a green. 15 out of 18.
3 and 7.
How many greens do I need?
3.
How many not greens do I need? 7. Probability of exactly 8 yellows after 12 draws.
12.
12,
12 C8.
8 out of 18.
You said 8 out of 18?
Uh-huh.
And then 10 out of 18.
8 and 4.
8 and 4.
I think we should call it a day.
Think we should call it a day and do the homework?
Yeah.
I mean, we can leave off odds till tomorrow.
Yeah, let's do it.
Oh, yeah. Okay, we can stop.
A lot to absorb for now.
Lot to absorb for now?